get started, as I was asking, are there any questions? All right, well, we were supposed to have a quiz today. I do, have a course planner. I tell you guys day by day what the plan, and I try to remind you guys of those things in class, but as you know, well, you may not know, I've been sick the last couple days, and so I haven't been, I reminded many classes of many things, but it slipped my attention that I should remind you have a quiz due today. But in my defense, I don't think I should have had to, because I made the course planner at the start to remind you every day what we're doing, and yet half the class is not here for quiz 2. So what can I do? So this has forced me to push quiz 2 back to Tuesday, and consequently test 2 to Thursday. That said, I still have the schedule. We have to get through stuff, so I have to go ahead to the next topic unless there are questions. So what I'm about to talk about will not be on quiz 2 or test 2, because this is test 3 material. All right? Again, you could stop me if you had questions about test 2 material, but if you don't, it's fine. In particular, what? What's on the quiz is not a question that's going. Like factoring. Now that's closer to a question. So what kind of factoring do you guys want to look at? All right, fine. Let's look at this one. So can you guys factor 3x squared plus 10x minus 8? Let's do a few things. Let's factor it. Over the complex numbers. My mouth is super dry. I'm going to have to get some water here, guys, in a second. Find vertex. Graph. Y equals to 3x squared plus 10x minus 8. Just a moment. So you guys try that out. This one could be ugly. I just made these numbers up. I didn't try to make it pretty. Oh. So I don't expect that this factors, So what do we have to do? There's sort of two paths, right? You could either use the quadratic formula to factor it, like I showed you guys. Did I actually show you guys that the other day? I think I started talking about it, but never actually. I maybe put it into practice, I think, in example 7 of one of our previous classes. So I'm going to use that. I'm going to use that idea. Because the completing the square here, I could complete the square. Your choice. What do you want me to do? Would you like me to complete the square to solve the problem? Yep.
I'm just saying it does factor out.
Oh, it does?
Yeah.
Really?
3x minus 2x.
Are you kidding me? 3x what?
3x minus 2.
Uh-huh. Let me give this thing a name. Let's call it P of x. Wow. We got really lucky. I'll make the next one uglier. Anyway, but let us wait till the trouble finds us, yeah? Okay, so great. You factored it. And let me take an extra step here. Let's factor that 3 out. See, that's x minus 2/3. Then once I do that, you can tell me, one of the things we need to figure out is the x-intercepts, right? Y-intercept, right? These are things we'd like to know. So now that we've factored it like this, what's this tell us about? This tells us what? This tells us that p of 2/3, right, equals to 0. The presence of this factor tells us that p of minus 4 equals to 0, right? So if you can factor, you should be able to see the x-intercepts, right? Or the fact that there are none, right? Where's the vertex? So I'll list our accomplishments up here in this. So we know x-intercepts at minus 4 and 2/3. How about the y-intercept? Somebody tell me that is. I'll put this one as at a point. Well, at where? What? Where's the y-intercept? Don't be shy. Somebody tell me what the y-intercept is. We find x-intercepts by setting y equals to 0, right? We find y-intercepts by putting x equal to 0, right? So if x is equal to 0, what's y equal to if y equals p of x here? Plug in x equal to 0, you get just the constant term, right? So the y-intercept is minus 8. Yeah. So again, where's the vertex? How do you guys figure that out? There's a few different ways we could go at it. I mean, one thing we know is that it's at midway between the x-intercepts, right? In fact, it's midway between any 2 points that have the same y value for the parabola. Just x-intercepts are convenient. But the vertex crosses through that axis of symmetry, so there's always like pairs of points on the parabola either side of the axis of symmetry which match. Just x-intercepts are convenient to think about because we find them anyway. So what's the midpoint? It's halfway between? Halfway between minus 4 and 2/3. That's one way you could think about it. What's the other way you could think about it? It's at x equals to minus b over 2a, right? That's a good thing to know about. Because with these x-intercepts, they're not a lot of fun to add, are they? Not particularly, but minus b over 2a, that's pretty easy to calculate, isn't it? What's b here? Thank you. So yeah, the minus b is negative 10, and then divided by 2a, which is 2 times 3, right? A is 3 here. This is a, this is b, this is c. So we got 6, right? What's 10/6? That's minus 5/3. Yeah. Does that match? How would you find the midpoint of 2 points anyway, by the way? If I've got 2 points on a number line, like 0.1 and 0.2, how do I find the point halfway between them? What's the formula for the midpoint? The formula is just this. You add them together, divide by 2. Yeah, simple as that. If you want to find the center point for like 15 points, you know what you do? Add all the points together, divide by 15. Any of you guys had physics? High school maybe? It's the same idea as the center of mass. It's just center of mass, we, weight, if you will, the points according to their mass, right? Okay, so anyway, if you use that formula, you'd have what? The midpoint would be minus 4 plus 2/3 divided by 2. What would that be? It better be minus 5/3, right? How many thirds is minus 4? It's minus 12, right? Minus 12 plus 2 is minus 10. Minus 10 over 3 divided by 6 is minus 10/6. The same answer. So that's where the x coordinate is the vertex. What about the y coordinate of the vertex? So remember the vertex we labeled h comma k, usual notation for it. So you could say that this x is really h, if you like. So we found h is minus 5/3. How do we find the k? Well, we can do k is equal to p of h here, because we're dealing with this polynomial. So all we have to do is plug in the h into the formula, and that will give us the y. So in this case, that is 3 times minus 5/3 squared, right? Plus 10 times minus 5/3, minus 8. I don't know what is wrong with me today. So we got some arithmetic to do there, right? I'm going to use my calculator in the interest of time and not making a silly mistake. Let's see here. So we got 3 times 25 over 9 minus 50 over 3 minus 8. I get minus 49 over 3 from the arithmetic there. Yeah? What? Okay. A decimal? Decimal's not bad. I mean, decimal's helpful for graphing, actually, right? Minus 16.33 repeated, All right, so what do we know? We know that the vertex is actually, so summarize it here. Vertex, where is it? It's at minus 5/3, and that's what? That's minus 1.66 repeated, basically, and minus 16.33. So, approximately, right? But good enough for our graph, certainly. And okay, so let's graph this thing. Now, what should I keep in mind as I'm making the graph? I need a graph that allows me to go minus 16 in the, down. And it needs to range from what? And I want to make sure I include the x-intercepts, right? So I need to go from minus 4 to 2/3. And I want the x-intercept at minus. So it's most of the interesting stuff's going on here below the x-axis, isn't it? So I will hazard a graph something like this. Let's see here. So I'll put 8 here, minus 8 here. Here's minus 16. You don't have to use the same scale for the x and the y-axis if you don't want to. This one, I think I can use the same scale just for the sake of, let's see here. So if this is, I'll try to use the same scale. I think I can, but it's going to make it look awful kind of narrow, but that's okay. So on the test, one of the things I wanted to do is to have a problem with graphing where you have a graph paper printed on the test, and then you have to graph on top of that carefully and accurately, where the squares will have the meaning of 1 unit each, probably. So I actually haven't managed to put that on the quiz yet. But anyway, so minus 1.66, which is like here-ish, right? Oh, sad. What's supposed to be a vertical line? That's x equal to minus 1.66 repeated, you know? And so the vertex is somewhere on there, right? It's where is it? Minus 16. So it's down here just a bit, right? That's like the vertex, right? And where are the x-intercepts? Should we let them in? I guess we could let them in. So the x-intercepts are here. And where else? Basically here. It's kind of hard to... Here and there. And as I said, you know, because I chose the scale to be the same for the x and the y, the parabola is going to look really, really, really steep. Sorry, my parabola is very, well, sketchy. So I don't put a ton of graphing problems on the test, like you create the graph, for a few reasons. Number one, it vexes my soul to grade them. Number two, they take forever to do properly, right? Like to do a good graph, it's about a 5-minute process at least, right? And also it's just hard to find an example which fits in the page in the way you want it to and stuff like that. The other way I can test graphing, and again, there's not a problem like this on the quiz. The quiz is predominantly focused on factoring because that's what you guys really, really need to get down. So the other way I can test on graphing is to give you, you know, like 5 graphs and ask you to match it with 5 formulas, right? So matching graphs with formulas is a likely test question, but not a quiz question. I'm warning you about this because I have told you before that the quiz is a practice test. And that is true to a certain extent, but I do intend to put some questions on the test which are kind of new. Any questions so far? So I think we should focus on factoring here. I'll try to stay away from graphing for the rest of today, all right? Do you guys want to take a picture or something? If you guys want to take pictures, I don't mind. Just don't take pictures of me. I tell my mom the same thing. I would tell my mom the same thing. See here. Come on. All right, let me find us some factoring questions. All right, so 4x squared plus 16x plus 20. I want you to complete the square. Then we'll get to the factoring, all right? But I do need to mention the completing the square thing. I will ask you to complete the square, I think, on the quiz. So what do I mean by complete the square? Well, first order of business, let's factor a 4 out, right? See that? If we factor 4 out, what do we have? We have 4 rather, times what? Times x squared plus 4x plus 5, right? So now we can complete the square, which is to do what? To take half of the x coefficient, which in this case is what? 4, right? So we take half of this, and we add it to x. So half of 4 is 2. we square that, right? Then we have to subtract whatever the square of that number is, which is 4. And then, of course, the 5 is still there. So that process right there, that is completing the square. Yep. That is completing the square. I got the minus 4 because otherwise it wouldn't be accurate. Let me break that down. If you're asking me how that number was created, another example, x squared plus 10x minus 177. Complete the square. X plus 5 squared minus 5 squared minus 177.
It was just half the x.
Mm-hmm. Mm-hmm. Right, so this one would be x plus 7 halves squared minus 7 halves squared plus the 10.
Okay, so I understand over there. But then how is it 4 over there? Oh, yeah, it's 2.
It just so happens that 2 squared is
You know,
half of 4 is also 2. The relationship between 2 and 4 is kind of, I don't know what's the right word. Yeah, that's a good word. Intricate. It's better than the word I was thinking of. So because 2 squared and 2 plus 2 are the same number is the thing, you know. It's almost never the case that multiplication and addition of two numbers give you the same thing, right?
why is it minus 4 squared? Because you squared it already, that's why it's 4, right?
Yeah, there.
Okay, that makes more sense. Got it.
That makes more sense. Okay. All right, well, very well. Very well. Let's see here. So, you guys are cracking me up. All right, so this is, we got 4, we've got x plus 2 quantity squared plus 1. So again, so I would say, I kind of like this for complete. When I say complete the square, I really want you to do like that, you know, like, you know, clean up your mess, do the subtraction, lump it together with a constant. Now, what if the instructions were factor over the reals? So if instructions say factor over the reals, then we're done, right? In fact, 4x squared plus 16x plus 20 cannot be factored. Because it's the sum of squares. That means with real numbers, we can't factor it. I mean, at best, see, the thing is, pulling the 4 out doesn't count as factored in this language. All right? I mean, you can factor out a number, sure, but when we talk about factoring a polynomial, we're talking about like producing polynomials of smaller degree, which are not just the constant that you can break it apart into. So like, because if it was just, if we always just were talking about like pulling out a number, you can always pull a number out of any polynomial. Give me one. 4. I can pull a 4 out of x squared plus 10x minus 7. Check it out. Yeah, watch, it's not complicated. 4 times 1/4 x squared plus 10/4 x minus 7/4. See, so like, right, you always have this freedom. It's America. That's not true. This is universal freedom. It's a mathematical freedom. It's for all mankind. It costs nothing except thinking. So that can't count because we can always do it. So when we talk about factoring a polynomial, this language, we're referring to something like what I could do over here. See if I finish this one? See what happened? Something rather ugly. X plus 5, or beautiful, depending on how you're feeling. What's 25 and 177? It's minus 202. So this is actually x plus 5 minus the square root of 202 times x plus 5 plus the square root of 202. Factored. That one we would not guess. I know, right? It is a mystery. But the main thing here is, So do you agree with this step? Like 20, all right. So it's just this. This is the square root of 202 squared. And so you can take any number that's positive, take the square root of it and square it. It's the same number. That's just an identity, right? Like, how old are you? 18. So you're also like 18 squared, square rooted. Wait, that's the other way around. Anyway, so you're the square root of 18 squared then. But that's still the wrong pattern. But anyway, the point is, if you take the square root of 202 and you square it, you still get 202, right? But the larger point there is that when you look at this and that, what you're looking at is the pattern a squared minus b squared, which is the difference of squares, which remember, difference of squares, special pattern, whenever we see it, we can factor like this, which is what I do here. It's just my a is x plus 5, and my b is the square root of 202. So that's also why completing the square is useful. It can always be looked at as a difference of squares. I say always, but if we're just working with real numbers, that ain't the case for something like this, right? I completed the square, and it's not a difference of squares, right? So that step doesn't happen. It has to come out to a minus here or a 0 to be factored over the real numbers. I am adding this. Notice I'm saying over the real numbers. I should say over the reals. So you might guess what I'm about to say is, because we have talked about complex numbers, right? What happens, like what if the instructions aren't over the reals? What if the instructions just say factor, 4x squared plus 16x plus 20 over complex numbers? How is it different? Well, the algebra is the same, all right? So it's still the case that you have 4x squared plus 16x plus 20, and you can still pull the 4 out, right? But then, excuse me, this is where the imagination comes into play, in the sense that I squared, right, the imaginary unit is minus 1. And so, since I squared is minus 1, 1 is equal to minus I squared, right? So what we have here is 4 times x plus 2 squared minus I squared. So yet again, we have difference of squares. Like completing the square always leads to difference of squares, or just straight up a square if it's the repeated root case. But it's a universal method for factoring a quadratic, if you don't see the factoring. Now, if you see the factoring like Sam saw earlier today, by all means factor. It is way, way faster, right? Certainly. Certainly. But if you don't, here it is.
So you made it.
Right.
By doing the I.
Yes, by doing the I. This is the thing. If the instructions say factor over the complex numbers, everything factors over the complex numbers because complex numbers are special. They're called a complete. They're called complete because they do this. It doesn't matter which polynomial you're looking at. If you have complex numbers to work with, it will break down into linear factors, possibly repeated. My apologies. So how about this one? Would this factor over the reals? We know it would factor over the complexes, right? Does it factor over the reals, this one? That one did, right? Work it out. We've got to do the arithmetic, right? X plus 7/2, quantity squared. So we've got minus 49 plus, I believe, 40 over 4. And tell me why I'm wrong. I am wrong in that arithmetic I just did. Explain to me why I'm wrong. Mm-hmm. Well, 10 is equal to 10 times 4 over 4, right? So that's 40 over 4. And it's plus 10, right? So plus 40, right? Wrong. It's a trap. What do we have to do? When we write a common fraction like that, we have to distribute the minus through the whole thing, right? So if I write this, I'm saying that I don't have a 10 up here, I have a minus 10. If you distribute this through, you get this 49 over 4 term, right? So I can't put plus 40 there. I must put minus 40 because I've got a plus 10 here. Okay? Be careful about that. And what's 49 minus 40? 9. Hey, check that out. So this actually works out pretty nice, doesn't it? Could you factor this one, Sam? No? It looks like it might be possible. I don't know. So you got 9 over 4. That's 3 over, well, okay, 9 over 4. Can you tell me what that is as a square? So 9/4 is actually 3 squared over 2 squared, right? Or 3/2 squared. So just to drive the point home again here, this is x plus 7/2 minus 3/2 squared. Difference of squares again, right? So we can again do x plus 7/2 minus 3/2, x plus 7/2 plus 3/2, right? Because I'm saying again here, this is the pattern a squared minus b squared with a equals to x plus 7/2. Yes, b equals to 3/2. I mean, there is a problem on the test where I say factor by completing the square or complete the square. Like complete the square is on the test, yes. Usually, completing the square ends here. Completing the square here, I would say, ends here-ish, you know?
Is there like, can you put like something on Blackboard of like all the things you need to know for the test?
Yeah, it's the course planner. It's already there. It shows you day by day what we're doing, and like the test is always on the material after the last test and before the next one. So like it's on systems of equations and factoring polynomials and like the identifying, term stuff like we did. Well, yeah, it's already there, but it doesn't have like a topic by topic or anything. That's up to you. Like that's, yeah, overall. But overall, it's not. Since you guys didn't let me get ahead to the next material, like I can pretty much summarize the things we've talked about after the last test, and up till today, pretty much. And I would say summarizing, it's systems of two equations and like the applications, like graphing lines and intersections if they have them, what that means, you know. How do you check if a solution is allegedly a solution to a system of two equations? What do you have to do? You have to put the x and the y into the x and y for both equations, make sure they both work out, right? How do you check something's a point on the graph? Well, you take the point and you put the x into the x and see if it outputs the y that it's supposed to from the formula, right? So same kind of story there. And we've covered how to factor polynomials all kinds of different ways, right? And we've just covered basic polynomial terminology, like what's the degree of the polynomial, collecting like terms, right? And then finally, we've covered a lot about quadratic polynomials because we have specific things we can do for them, like we can find their vertex, we can find the x-intercepts, if they have them, right, y-intercept. So we know much more about the quadratic case than we do the general polynomial case. Like, if I was to ask you, you know, is there a vertex for this fifth-order polynomial, that wouldn't be a meaningful question. Is there a vertex for this cubic? Is there a vertex for this quartic? Those are not meaningful questions. The vertex is something that we study for quadratic polynomials, and so that's where we know most of our most precious results. But look at this, like this. But okay, so this example here is an example of how not to factor this, because what we're going to get to here is what? What's 7 minus 3 is 4. 4 over 2? 2, right? What's 7 plus 3? It's 10. 10 over 2? 5. So my question to you now is, can you factor this? You guys can factor that. You don't need to complete the square for this one, right? Because 2 times 5 is 10. 2 plus 5 is 7. So this is actually like basic factoring.
So like on the test, do we have to show all that stuff to it, or
Absolutely not. For this, well, it depends on the question. If the question is complete the square, then you have to complete the square. If it says use completing the square to factor, then yes, you would do these things. If the question just says factor, well, you can do whatever you like. There are, so it's here. So let me take off the reins here for a second, and say put some examples up here. Let's see how you guys do. X squared plus 13x plus 36, because, you know, I do spend a lot of class time talking about more complicated things, but the basics do matter. So let's talk about them, because a lot of the test will be the basics. You guys try just see, factor these. Yeah, no completing the square, just factor them. I don't think you need completing the square for these ones. So I might well give you 10 of these on the test, you know. They shouldn't take you more than a minute.
to do 10 of them, or one?
One. I mean, 2 minutes maybe. Some of them you should just do it. You can do it.
Well, yeah, would you factor out the first one? There's nothing in the next.
I mean, I can get it started for you if you like. This is X and come on. This one I would try. No, this is guess and check factoring, which is the first thing we did. I only introduced the completing the square after we got stuck on certain problems. I heard it plus 4 plus 9. I'll allow it. Everybody else allow it? What do you think? Math, I sometimes tell you guys math is by consensus, so somebody here to fact check your answer would be in trouble. I don't know. Uh-oh. What did you do? What just happened? Are you censoring something for me?
No, I just know the answer.
Oh. Anybody want to tell me how to do 4? What's that? Yeah?
It's 7 and 3.
7 and 3.
But I don't know which one is plus or minus. Whether it's plus or minus.
I think you need them both to be negative. See, if you got a plus, you either need to have plus plus or minus minus. Them's your choices in order to get a positive. So minus minus is the way you got to go.
Like, for example, plus one, if there's positive, then it's going to be positive, right?
Well, having a positive 36 means it could have come from a product of 2 positive things or a product of 2 negative things. But because I've got the positive 13, I probably want 2 positives.
So how did you know it was 2 negatives the second one?
Because I got this. But it's not quite as simple as that. Like there's a battle of which is winning, and you have to you really have to think about adding minus 3 to minus 7 to get minus 10. Here 4 plus 9 is 13. Really the question is, when you multiply it out, do you get back the middle term? It's always that. If you multiply it out, do you get back the middle term? Like this one down here, I've got a minus 72, right? So minus 72, well, that's 8 times 9, right? So either the 8 or the 9 is having, I can either do 8 times minus 9, or I can do minus 9 times 8, right? Did I say the same thing? I can either do minus 8 times 9 or minus 9 times 8. One or the other of those is going to win. I better make the bigger one positive, because it's supposed to give a positive middle term, right? So I do plus 9 and minus 8, because I see that I want the positive to win. But the ultimate, do number 8. So 50 is what? 5 times 10. It's various other. I'm going to try 5 times 10. That feels like a winner. In order to get a 20 here, I got to put. That doesn't work, huh? It's also 2 times 25. No, that doesn't seem That doesn't seem helpful. Did you guys get this one?
Yep.
What'd you get?
2a minus 10, a minus 5.
2a minus 10. Ah, okay, yeah. I talked myself out of that. I shouldn't have. So minus 10 times minus 5 is 50, and this gives us minus 10, and this gives us a minus 10a. So again, factoring is reverse multiplying. The way to check factoring, once you guess a guess, is to think about multiplying it out. All right? That's why we must practice, so it's a shorter time. Yeah. But more to the point, you can focus your attention on the part that matters, which is this, right? So where does that come from? That comes from this times this, right? And that times that. See, this number over here and that number over here are really irrelevant in the question of checking, because they're not irrelevant entirely, but the most thing to focus on when you're making choices is the middle term, because that's what you're trying to sort of sync up with. How about the last one? 5. 33 is 3 times 11, isn't it? And we need to make you need to have like a plus or a minus or a plus, right? But you want a negative middle term, right? So I think that means you make the bigger factor win. Well, in the negative sense, right? So I think I go with minus, what's that? Minus 11 plus 3? Yeah, so when I look at the cross terms, I get minus 11 plus 3, which is minus 8. Any other questions? All right, well, I think we're done for today.